Next, we've got cross-origin resource sharing, or CORS. This is a feature that comes up in real-world scenarios as well as the exam. CORS enables web applications hosted on one origin or domain to securely interact with resources on a different origin, such as cloud storage, which is what we're talking about in this case. The cloud storage domain is storage.googleapis.com, and so this would allow applications hosted on one origin potentially to access resources on storage.googleapis.com. So this is particularly useful for client-side applications that need direct access to upload or download files without involving a backend, and that simplifies the architecture. This is with cloud storage that we're talking about here. So from a security perspective, CORS ensures that only authorized origins can access your bucket. You define these authorized origins through a CORS configuration policy. For additional security, it can be used with signed URLs as well. So the combination of them can add another layer of security. Now let's look at a diagram at the bottom. It's a simple diagram, but it does illustrate the concept well. A user's browser sends a request from another domain, such as yourapp.com. I'm just using that as an example, to a cloud storage bucket. And this is what I was talking about, where storage.googleapis.com is not the domain where the request is coming from, but if CORS is enabled to allow requests from yourapp.com in this case, then the request is allowed to pass through. So that's the entire point behind CORS, and it's literally spelled out in the name: cross-origin resource sharing. The request is coming across two origins, from yourapp.com to storage.googleapis.com. So CORS checks the origin against the bucket's CORS configuration. If the origin is authorized, the request is allowed. So then uploads and downloads can happen. And if it's not, then the request is rejected. So this is a straightforward way to securely manage cross-origin requests for web apps. And it could show up on the exam. Now I'm going to walk through a use case for this using CORS and signed URLs in the context of a specific scenario, that is a photo sharing app that uses App Engine. So let's start by looking at a diagram and then kind of talk about it. So first, we have in this photo sharing app users that interact directly with their browsers, and they're going to try to upload images. The process begins when the browser sends a request to the application that is running on App Engine, asking for a signed URL. The App Engine app generates the URL, which acts as a temporary credential, and sends it back to the browser, like that. And then the browser uses this signed URL to upload the photo directly to a cloud storage bucket. During this upload, the CORS configuration on the bucket validates the origin of the request, ensuring that only authorized domains can interact with the bucket. In this case, it would be the domain of your app on App Engine. So this setup improves efficiency by allowing direct uploads without routing your data through the backend. Now, summarizing with some bullet points here, it enables users to upload photos directly to cloud storage from their browsers while ensuring secure communication through CORS. The app's front end, in this case hosted on App Engine, manages signed URL generation, and CORS ensures that requests are validated and secure, while signed URLs, in this case, make the upload process efficient and also more secure. So this is the kind of example that could show up on the exam, something very similar to this. And since this might appear on the exam, it's worth going over that the CORS configuration can be set using gsutil CORS set. And then you would pass a JSON with the configuration and specify the bucket. All right, that covers cross-origin resource sharing, or CORS, in cloud storage.